Here's an interesting statement. Differences in the solubility product constant values can help us separate ions by selective precipitation. Well, this brings up the idea of why do we care? There's a lot of reasons to care. If you are in the mining industry and you're trying to extract a particular metal from ore that has all sorts of things in it, you're going to want to know the best way to get all of what you're trying to separate out. If you're in water quality, you want to make sure that certain ions don't stay in the water because they're not good for the people drinking it. So there's a lot of reasons to do this sort of a problem. And here we have a water sample containing barium and calcium. And the question is, if I decide to do a precipitation of the calcium fluoride, can I separate it from the barium? And then, of course, if you're going to say that, you have to come up with an actual guideline for what does that mean. And this is complete removal is defined as the remaining value being 0.1% of the original value. So you're going to get 99.9% of it to precipitate. Okay, that's what you're going to try to do. And the question is, will this particular set of molarities actually make that happen? Okay, so we shall start with number 19 then. We are told what the concentration of the barium is. And we are told what the concentration of the calcium is. If we go look up the KSP, well, they say you're going to be doing this by precipitating calcium fluoride. So we must be adding fluoride ions to this. So I'm going to want to look up the KSP for the barium fluoride, which would be the other thing that could conceivably form when I throw all these fluoride ions in there. So when I look up the KSP for barium fluoride, what I find is that it is 1.84 times 10 to the negative 7. And remember how it is made up. It's the barium concentration and then the fluoride ion concentration, and then because there's 2 pluses and only 1 minus, it means there's 2 of these, so 2 up here. And the KSP for the calcium fluoride, same idea, but we have to go look that up, and we find out that it is 5.3 times 10 to the negative 9th, and that is made out of the calcium concentration and then the fluoride concentration squared. So we have these set up. And we can look at this and see with the numbers, since this one's smaller, it is going to happen first. As the fluoride concentration goes up, it's going to trigger this before it would trigger that. This one is the smaller number, so it happens first. You're going to reach that number first because you're starting from 0 and ramping up. I want to know when to stop precipitating this. So I'm really interested in when would this one start? Okay, so when would the precipitation of barium fluoride start? Because when that starts falling out of solution, then I'm going to end up with these things mixed again, and I'm trying to separate them. So I'm trying to say, I want to precipitate this, but I don't want this to start coming out too. So I need to know what level I need to keep the fluoride ion concentration below. Okay? Well, they told us what this is, and they told us what the overall is. So I'm just going to say that I'm trying to find out when 1.84 times 10 to the negative 7 equals, let's put this number in, 0.0375. And then I'm interested in the fluoride ion concentration, which happens to be squared. Well, you could just put x squared here, but you know, then you'd have to keep track of what x meant. So I'm going to go ahead and use the concentration here. This would happen when the fluoride ion concentration squared was 4.91 times 10 to the negative 6th. And if that is true, I have to stay below that when I'm doing this. So that's some sort of a cutoff. So I'm going to use this as a cutoff value for F minus concentration. If I were to go beyond this value, and mind you, I'm not even bothering to change it. I'm doing a shortcut here because you see this also appears exactly the same way here. I'm not bothering to find out what the actual fluoride ion concentration is. I'm just saying, oh, since they match exactly, I'll just stay with this. So, but it gives me a cutoff value for this. I don't want to go above this because if I do, not only will I precipitate this, I will start precipitating this, and then I'll be getting them mixed together again, and I don't want that. So at this cutoff value then, what is the concentration of the calcium? So I started by using the one with the fluoride in it. I mean, not the fluoride, they both have fluoride, the barium in it, to figure out this cutoff value. And then I said, and then what would that have for an implication for the value of the calcium 2+? All right, so I'm going to go ahead and put this value in here along with that to find out what this is. That would mean the calcium concentration would be the 5.3 times 10 to the minus 9th divided by this fluoride ion concentration, which I already know what that is. I'll go ahead and I'll write it this way though first, just so you see all the steps. Put in this one that I just figured out, including my shortcut of not bothering to find out what it is all by itself. I just used the squared. And I would end up getting from that 0.00108, which is definitely less than it was, right? It started at the 0.0667 molarity, and now it's down to this molarity. Okay, that's good. That means I have removed a lot of calcium ions in the form of calcium fluoride, and I haven't contaminated it with any barium fluoride because I haven't gone over this number. Now, it says, can they be completely separated? Okay. Completely separated. And then they give you this little thing, 0.1% of the original value. Oh, well, then I should compare this to the original value. Okay, so I'm going to take my new value, the calcium now, compared to original. And because they have it as a percentage, okay, times 100%, we'll turn it into a percentage. So I'll put the 0.00108, divide it by the 0.0667. The molarities cancel. Turn it into a percentage, and I find out that, it is still 1.6%. So even though I have managed to precipitate out 98.4% of the calcium, I have not managed to have complete removal. So it's not complete removal, sadly. But it's not bad. It's a good start.